more stamina than I have. He has more resilience.
Okay. I think it's time to get started. Thank you all for joining the SCITT working group meeting today. Happy to see you all here. We have seen, John and I have seen a number of you at the hackathon. We'll talk about that a little later in the agenda. But before we get to the agenda, let me quickly zip through some of the welcome slides, which include the Note Well, which is described in a number of BCBs, which are listed at the bottom of the slide, which you are supposed to be familiar with. Equally, there's an RFC 7154, which describes the code of conduct, which asks you to be polite to your fellow working group participants. And also some tips regarding the Meet Echo usage, which I guess you are all familiar with because we have these regular conference calls. And so you have been trained in using Meet Echo in the meanwhile. But there's a blue sheet wandering around somewhere, and that contains a QR code. If you haven't scanned the QR code yet, please do so. So you can actually add yourself to the queue, and we can also record your attendance. That's quite important. This slide just shows a couple of pointers with meeting material, meeting minutes, etc. What is probably more important is the meeting minute taking. So I'm going to take some notes, but I would appreciate if you could help me complete those notes specifically, and if the discussions get a little fast, I might have difficulties catching up with all the discussions. The link is also found in the Meet Echo, as you've also seen during our weekly conference calls. Is there anyone who is going to join and help me out? Awesome, thank you. Roman?
Hi, Hannes. I just wanted to toss out an administrative thing kind of very early. You were talking about meeting minutes from kind of previous meetings. I know this working group has a very successful weekly cadence. I just wanted to remind folks there's a thread on the larger IETF mailing list that is a reminder to certainly working groups that have these high cadence regular meetings. Please be sensitive to the fact that folks check agendas kind of advance and may make decisions about whether to join the meeting. So again, all the right things are kind of happening, but just as a reminder, let's make sure agendas are out, minutes are kind of done. And so this is all kind of very important, what Hannes kind of pointed out. It's important for the transparency in the organization. So thanks.
Yeah, that's important. Yeah, we tried to, so we had some problems scheduling the meetings and putting stuff out there. Those were largely technical problems, just didn't show up on the list and these type of things. But it got better recently, and I've also posted mails to the list to explain what we are going to talk about. And some of the topics obviously surfaced on the meetings before, but we highlight this. In fact, actually, just yesterday, after discussion with John, we've sent out another meeting invite for next week's Monday meeting with the agenda topic of a kind of a post-IETF discussion, just checking on what has happened, who has what action items, what do we need to do next, and so on. Okay. So the updates since last IETF meeting, as mentioned, we had these conference calls. It took us a little bit of time to get those scheduled because there was we wanted to give everyone a chance to voice their opinion regarding the day of the week and also the time slot. But in the end, it turned out that the most preferred slot was actually the one we were already using. So it turned out to be a little useless exercise, but I think it was still worthwhile to do that in case someone or a larger group of people suddenly decide to that they have now changed their schedule and so on. So I think it was good.
Yeah, Hannes, and to you, John, and the chairs, I kind of want to thank you for that. I mean, this is exactly some of the substance of the discussion on the bigger community thread that working groups that meet regularly should regularly kind of check for new participants. And so you are following kind of all those processes, and kind of thank you for leading by example.
Yeah, it's yeah, it required a little bit of extra effort for everyone, but I think from a perspective of being inclusive to participants throughout the world, I think it was important. Okay. Folks in the group updated the architecture document in time for the deadline. Thanks a lot for that. And we have a discussion later on in the agenda about this. And then the use cases has not been updated. So there, I will bring this up again in the discussion slot on whether that document is maybe close to being wrapped up. So that may, of course, be good. We removed the reference to, or we moved the text from the about the use cases from the architecture document, pointing to the use case document. So I think everything in terms of use cases is now concentrated in one document, which is good. Okay. Another thing in terms of outreach, we obviously have been talking to various different folks over the last, let's say, a year from different communities who work in supply chain security areas, and have invited them to join our conference calls to share what they are doing. And of course, if you know someone and know a group who's working on that topic, we're happy to have a presentation or some discussion about what they are doing and how it relates to what we are doing here. And it was most recently we stumbled across an ISO group 22373, and that there's a working group in ISO, a working group 4, which works on authenticity, integrity, and trust for products and documents. And they are working on a framework for supply chain trustworthiness. And John and I have been talking to participants in that group, the convener of the document, if that's the right term, of this framework document. And we are going to work out maybe a presentations of like presentation to their group from our side and vice versa, so we are all on the same page. But my current understanding is that this work we are doing here in this group nicely fits into or aligns well with what they are doing. Theirs is a more abstract framework, while ours is a more specific instantiation of that framework, kind of an implementation of what they are doing. So, but I'm looking forward to that information sharing. We'll schedule something during like the next 2 months or so.
Yeah, certainly before 118. We need to get that going.
Okay. Yeah, we plan to continue holding these conference calls. They have been quite useful. People, it's like obviously we also ask them whether those who participate in those calls thought that they were worthwhile or we should change the scope of the calls. And we got positive feedback, and yeah. And also we will run them through the summer vacation period, even though some people may not be able to join for some weeks, but we will, any decisions that are made will have to be confirmed on a mailing list anyway. Okay, last slide. And so this is again a reminder about the agenda. So next is the hackathon report, which John will walk us through from what happened during the last 2 days. Then we focus on the main topic for today's meeting, which is the architecture. And then we have some buffer time to talk about anything you like. And that's it. Almost anything you like. Any agenda bashing, any feedback? Or you're good? Okay.
Okay, so yeah, if you do that. I'll just ping you from slides. There you go. Yep, so it's me again on the hackathon, because I don't get to write a lot of code in my day job, so I do it at weekends here instead. Is it? There you go. Okay. Thank you for flying Spirit Islands. This way? Okay, this is not, I'm learning every day. Absolutely. Okay, so if you hit the button, please, Hennis. It was a very active hackathon again. We always have this sort of mixture of spec hacking and code hacking and idea hacking. So lots of stuff happened. I'm not going to go too much into what happened in the spec hacking because the architecture update later will cover all of that. But it was a great active team, lots of people taking part, and I just have the privilege of presenting what sort of came of that. So hit the button again, please. So it's worth remembering or explaining for people who are less regular members of the SCITT working groups what we fundamentally set out to do, because it can be sort of distracting or confusing drawing a line between technology and applications, or drawing a line between security and privacy and transparency. These are all different but only subtly different things, and SCITT fundamentally is defining some building blocks. It's not a full application, but it's defining useful interoperable building blocks for enabling sort of supply chain type use cases. And the fundamental promises, this is just a quote from near the top of our architecture document, there are three fundamental things that we're trying to do: making sure that you have authenticity, making sure that you've got proof of origin of your artifacts and statements, making sure that you've got non-repudiation, so people can't, there's no takey backies, no shredding. If you've put something into a supply chain process, then it stays there and is reliable, and so on and so on. And then down to the other issue of non-equivocation, which is a big difference here. People often ask, why aren't we just signing stuff? A big reason for that is non-equivocation of statements. So you can't say to one person, hey, this is the contents of my software package, and then you say to your auditor, hey, no, this is the contents of my software package, and everybody goes away seemingly happy, but you've never actually made any improvement in the world. So it's important to remember those promises, and these are the kind of things we're trying to prove. So button, please, Hannes. I've gone through that already. Hit again. It's my cute trick of highlighting. So the intent of the code hack, bearing all of that in mind, was to see if we can actually build a useful supply chain integrity, transparency, and trust application on top of the building blocks. And again, I use those words advisedly. You don't create a whole application out of the building blocks because they're not enough on their own. But is it possible to do something useful using those as a sort of critical key interoperability point for the necessarily multi-party and multi-application world of supply chains? And a couple of things had really started to surface in our regular cadence calls over the last few weeks in the areas specifically of indexing. This came up a little bit at 116, but it's really come up in recent times of how do I is that off? No, it's still not off. That's okay. I don't think it's picking up here. So the yeah, it's the Meet Echo. That's why you have the on-site tool, but it's fine. Get my thread back. So one thing with supply chain evidence is you've got multiple different ways of finding and assessing and relying on it. Sometimes you might have a thing in your hands, and the question you want to ask is this the right artifact? So did it come from the right place? Is it still, has it been tampered with? Has it been superseded or revoked? That kind of thing. So I've got it in my hands, very simple. I simply check it. And in that case, the cryptography is kind of easy and straightforward and everything worked. But there are many, many more messy situations where you maybe don't have the thing in your hand, or you know what thing you're looking for, but you don't know where to look for it, or variations on this theme. So we absolutely didn't want to specify in SCITT itself a generalized deep semantic search feature, but we do want to make sure that applications are capable of having deep semantic search features for their specific silos that are then translatable and relatable and deterministically bound to or related to things that end up in the SCITT transparency service, so that the world carries on. So it's a bunch of those things, and where we'll see in the architecture section later some updates on sort of very specific wording or whatever, where the outcome of this hackathon was supposed to land at is, where do we actually draw that architectural line? What is the boundary between very low level cryptographic primitives and little building blocks that allow you to create a Merkle tree proof and things that are able to search global registries of software and decompile them and exquisitely determine full, from binary SBOMs, and get in between those things, and where do we draw that line in SCITT? So if you hit the button, please, Hannes. So I had a plan. I posted this to the mailing list. I hope you all saw that. Sort of pre-committed what I was hoping to do, and the outcomes that we were looking for was to show end-to-end demonstration, attesting and verifying a vendor response form. So again, for folks who haven't been in the meetings, this won't mean anything to you. But Dick Brooks, one of our more active members, has a use case for medical devices where, similar to a lot of the software transparency regimes going on right now, they're not necessarily going as far as having automatically verified SBOMs and so on sort of in public on transparency ledgers, but they do have to make very strong attestations to claim, yes, we've been through due process, yes, we've done the right steps, and here's where you can find all of my information. So if you need the SBOM or you want my security reports, here you go. I'm living in some degree of public. So we agreed that was a good test case. It's generalizable to many other test cases, and we wanted to show that you actually can use SCITT to assist that process of publishing and verifying VRFs. We wanted to drive the spec forward, understanding where particularly company identifiers come up. So this is a subtlety, it's a little detail of what we're working on in the working group. But the idea of identity is in one sense super duper important, and in other senses kind of irrelevant. And what we need to do is unpick why we have identities specifically in the SCITT layer. So again, when you've got a whole application and business is running applications, it's kind of obvious why we need company identifiers and logins and all sorts of things like that. But very specifically in the supply chain integrity components, what does it mean to have a company identifier? Do I actually need to know, next to the cryptography, what the Dun & Bradstreet number of a company is or what their tax status is? Or actually, do I just need to have something in the syntax that allows me to ascertain that a statement coming in today was created or issued by the same entity, for whatever that means, tomorrow, right? And these are very subtle, and I see people in this room who have been wrestling with this for well over 20, 30 years by now. And we'll never solve that problem, but we can solve the problem of what part of that layering SCITT is concerned with, and that's what we wanted to push forward. And then the other big one, as I mentioned a moment ago, indexing and storage and search and all of that stuff. It's definitely an application layer question, there's no question about that, but how do we actually support it with the SCITT building blocks underneath in a way that is sort of commercially supportable and maintainable? And if you hit the button, please, Hannes, fast forward to the good bit, that should be ticks. Meet Echo needs to have Unicode support. So we did all of these things. All of those things were proven to some degree. So I didn't actually manage to do one important thing, which was interoperable submission of plain claims. That's a thing that was left over from last time. I didn't get that into the interop client, and I failed to get it into the interop client again. But we did prove lots of these other things. So yeah, button please, Hannes. So what we can see on the screen, actually just hit it again, nobody can see the detail here anyway. So what you can see on the screen here is the slides are downloadable, right? So if you want to see the detail or spend longer, see the detail, get a microscope out on the slides, you can do that later. But for these purposes, all we need to show is in my application, which is very much a hybrid application. So it's kind of Mongo databases and all sorts of regular Web 2 cloudy stuff on the top, and then it's Merkle trees and things all the way down on the bottom. I was able to pretty easily plumb together sort of search, index, and then attest that through standard SCITT cozy envelopes, and then go back around the other way with the interop client and pick up the, retrieve the signed claims and get a receipt and verify the Merkle tree proofs in that receipt all the way end to end. So something that's not on here, maybe I'll record a video or something if people are interested, but something you can't see here but is important is that using that application level searching by certain keyed indexes or indeed by hashes of the payloads and things like that, is that you are able to search for those three promises. So it's not simply here's a receipt for something, because that's still very equivocable, but rather you can actually take that payload, assess it in the higher level indexed application and see, no, this is the only one we ever had. And by making other signed statements or by putting out other, we had a rather joyful conversation about QR codes recently. If you want to put a QR code, a physical one on a box somewhere, so something that some of my customers already do, then you've got a fixed, what we call a feed of the attestations and the signed claims against a particular thing that then can't be equivocated or changed, because people just see this one set of stream of statements, which is kind of the last missing bit to making this VRF, ultimately, which is what we're doing, trustworthy, because you can be sure you've got the right one and you don't have to keep doing those manual processes or checking for second versions or whatever else it might be. So yeah, so we got it working and it's cool and it's completely demonstrable. If people want to see a demo, as I say, I might just put a video up. So slide, please, Hannes. So Dick has kindly provided some updates of this. We did say end to end, and again, many of us here I've worked with in a former life doing things like end to end or point to point encryption, and the question is, well, what happens either side of the points or on the other end of the ends, and it never ends. So we've got a nice self-contained SCITT end to end that I did during the hackathon in this room, which just shows the registering of the signed claims, turning them into cozy envelopes and then CBOR receipts. Dick then took that a step further. So what we've used here is a real vendor response form. Again, you can't read it on the screen, but it's all checked into our GitHub and things. So treat this as a...
Yeah, and it was on a mailing list too.
Yeah, it's on the mailing list as well. So you can get these and look at them if you want the detail. So Dick actually went and took it a step further and plugged in my implementation from the room downstairs into his real software attestation and trustworthiness verification software. And if you press the button, please. And one more, it's kind of a build here. You can see as part of lots of things that are going on, because this is still a messy world and there's lots of processes you have to go through, but in amongst the pile of evidence that's being assessed by the REA tool that Dick's working on, it's actually able to use the attested, properly receipted, properly SCITT, I don't know, armored, whatever, reliable file from our registry. And obviously, the more things you start to put into the registry, the more of those can be automated and trusted and shared around between tools. So the upshot of the hackathon, successful collaboration. I mean, Dick and I didn't really speak very much during the weekend, but we were able to collaborate using the SCITT primitives, using the implementation to get a fully end-to-end example of a searchable middleware, a SCITT underlay, and an actual commercial tool that's able to use this technology to better prove trustworthiness in digital supply chains, which I think is a great thing. And thank you to Dick for doing that extra work. So one more. Yeah, so just to summarize, the VRF use case was proven end-to-end, and I think that as I said, it's very generalizable, doing that kind of thing. It's notable that it's a complete payload, so something that might not be entirely clear. We put up sort of XML files and we put up JSON files. It is obvious, to say obviously, it is clearly, maybe use that word, it is clearly easier to generalize cases where the whole payload is sort of consistent or self-integral, meaning it's kind of all or nothing. it would be much harder to maintain the kind of clean architectural layering that we've proven and going through if you had to actually look inside each individual element. You know, the VRF includes things like tax numbers and email addresses of contacts, and it has a set of sort of product codes in it. So the software supply chain assessment tool, the risk assessment tool, the CI/CD systems, whatever you want to call it, the thing right at the top, the application that actually processes this data, obviously that has to go through and look at the detail and pick out bits it's interested in and go off and reach across the internet to look for VEXs or VDRs or whatever else. But what we managed to do in SCITT is, as long as that is a discrete payload, this generalizes perfectly well to any tool, or more recently, lots of tools, all picking up the same thing, knowing they're working with the same thing, knowing they're working with the same data, and then whatever their special application use case is or their business logic is, they're able to do that in confidence without having to request another copy or having lots of bilateral signature arrangements or something like that. So that was very good. A couple of other use cases. So Ray, I think, has Ray gone home?
Yes. She did.
Yeah, Ray's not here today, but Ray was Ray Lutz, another of our very active members, was here for the weekend, and his primary use case is actually looking after the integrity of votes, citizen voting in particular. We had a good chat about applying this sort of proven technology to his use case. It seemed to work and make sense. And we also had some good sort of first time, second time I've called you out, I'm going to keep doing it. First time participation from AJ looking at, again, that higher level issue of, let's say I've got vulnerability information or something, or a bunch of SBOMs or 10,000 CVEs, looking at digging into the detail of that and working out, well, given that I now have a trustworthy source for CVEs and so on, can I use the interoperable SCITT emulator to work that out? And I think we haven't answered that yet, but it's looking like it's trending in the right direction. So challenges, I'll assume I'll recognize you after this slide.
Sorry?
Yeah, okay.
I was hi, Roman Danilio.
Yeah.
I was just asking about the election use case. I was trying to crosswalk that against the narrow charter scope of software only.
That's an interesting question. It's digital, so there are software elements to it. There are non-software elements to it as well. So it's a good question. It's a thing we haven't worked on yet. So we could look through that. We've got Roy too now.
Actually, there's Roy Williams. When we chartered, we actually expanded out past software.
Yeah.
Saying the building blocks are valuable for other scenarios, and that's why we pull in some of these other use cases. So this is perfectly acceptable as far as my understanding.
Yeah. Well, so my recollection, and I think my recollection is documented, is that indeed, and we have the use cases were accepted with the cold chain use case, I think, as evidence of that. But we did commit to solving or prioritizing, let's say, the software use case first. And I think that's what Roman's getting at, is that if we don't have that done, then we can't very well move on to the other ones. But I think we are very close to having that one done. And then hopefully we'll be able to move on to other ones. Ray, are you in the clue, Ray?
Yes, thank you. And thank you for pointing out this this application area and use case. I will just say that that there isn't any real fuss that's required for supporting this within the SCITT structure that I've seen so far. And so it isn't really going to require any special extensions or anything else. It's a very simple thing, really, to capture the data from the election and just post that and provide the hash value of everything up to the SCITT servers for visibility, so the public can see it. And that's just pretty much it. I will jump in later about the identity issues and the different flavors, because I think maybe some more work needs to be done there in order to lock those down a little bit more. But that really is beside the point. But there's really no worry, I don't think, about this diverting the focus. Thank you.
Yeah, thanks, Ray. Hank?
Yeah, oh, thank you. This is Hank. So there are other things that are very software lifecycle specific, like the secure self-attestation form that is now out for review. That's the PDF.
Right.
And I think you can print it out and check mark things on that. But it's also very much about the endorsement of the quality of your software, or what's called attestation. Let's not talk about that. And I think that's part of the software supply chain use case scenario. So there's a lot of things that are actual software that are, of course, part of the software supply chain. And if we reach a border where Roman feels actually a little bit uncomfortable by us pulling it in, I think rechartering that part of the charter should also be not a big issue, I think. Yeah.
Yeah, cool. It's always worth, I mean, when we come up on our year mark, I guess we should do a quick check anyway. It's just good to do the health of that. But yeah, the ultimate good news is that actually it seems like once we've sold the software supply chain, everything else just fits. So it's, as Ray said, there's no intention, and we think no necessity to do anything that would derail that. I can't see the queue, Hannah. So if you want to,
Neil.
Yeah, Neil.
Hi there, and thanks, and congratulations on that progress. I just had a question for really all of you. I mentioned it in the chat, but SigStore is doing some similar work, and especially for this kind of simplified one-off, self-contained document. I wonder if SigStore would also fit the bill for both the ballot images and some of the other things that you demonstrated.
Well, if they want, so they're welcome to pile into the Interop client, and if it works, then great. I think we did some weeks ago now. We did have that discussion with some folks. I don't know a huge amount about where their integration hooks are, so I wouldn't dare to speak on their behalf. But we did have a couple of discussions with folks who work on it, and it seemed like it could work. So I guess it's a motivation question. So we'll take, I think we've got one more in the queue, and then we'll take Christopher.
Yeah. Christopher was first. I think.
Okay, well, there you go. Yes. So.
Yeah, I'm Christopher Allen with Blockchain Commons. I don't know, this may be more appropriate for the architecture document discussion or whatever, but it seems to have come up repeatedly in these questions, which is I have some real concerns in regards to engineers as people and having human rights and other challenges with over-identification and unnecessary correlation. And I'm really concerned that we're not including them. I mean, we have two RFCs, 6973 on privacy considerations, but also 8280, the research into human rights protocol considerations that we're all supposed to be considering, but I don't see anything explicit in any of these documents about that. VRFs were specifically designed to allow some kinds of privacy, but don't address signature correlation. I saw that there was some work on, say, COSE Merkle. COSE really wasn't designed for data at rest. It was really designed for data transfer. So I'm a little concerned, and I don't know, maybe you guys in the hackathon, when you did the Merkle stuff, were able to do some elision or some other techniques. But there are very specific use cases. I mean, there are engineers in India right now that are being monitored as they write their code, and every time they use Reddit or use, a Google, not Google, a Microsoft Code AI or whatever, is monitoring their usage of all these sites and basically logging it so that their employers can know, did they actually write the code, or did somebody else write it, or did an AI write it? I'm just seeing lots of these kinds of intrusions against individuals, especially in India, China, other subcontracting realms of things. And some of these have definitely are costing problems now. I know of a Iranian software engineer who's not in Iran, whose family was threatened because of the work that he was doing in the US around human rights software. So, you know, what did you consider in the hackathon, and what, you know, how did you use the Merkle trees and the VRFs, and what can we do to solve this problem? Thank you.
So I think other people, and I think the architecture section might cover the details, but just to say a couple of things. One is that we, at the SCITT level, which is a very low level set of building blocks or interoperable proof of lineage, effectively, and origin, we are strictly payload agnostic. We do not dig into what's inside the payload. We do not semantically interpret what's inside the payload. And so it is completely neutral on if a thing includes that or not. It would be a different layer. On the keys and correlations and so on, yeah, we are really looking at the company level. So the likelihood is that the correlation you'll find in many cases is some kind of service credential for a CI/CD system. We really don't need to get into the details of exactly who did the what and committed a thing and was Git blamed for wherever the commit came from. So I hear what you're saying. I think we're compatible with what you're saying, but the specific concerns would be handled in a very different layer, I think.
Yeah, I'm just concerned. I mean, if you don't have a fundamental capability of doing things like various forms of elision and proofs, whether or not they're elision proofs of inclusion or ZK proofs of inclusion, you know, various ways of using VRFs in other ways to do different kinds of verification without actually having the data. If you don't have those fundamentals at the bottom layer, you can't fix it in other layers. It has, you know, at least have to have some basic capabilities to support these types of things, or BBS signatures, or I don't know what the right answer is. So.
Actually, yeah, I should clarify that the VRF Christopher is talking about is the verifiable random function, which is totally different than what John was talking about, the VRF, which is the vendor response form, which is essentially a collection of S-bombs and some other metadata. Of course, unfortunately, three-letter acronym sort of collision here, but yeah, but the point is taken is definitely something we should double check, specifically like in context of the discussion we had with Keytrans on their use of VRF, the cryptographic function, and whether some domains require additional privacy features beyond what we are currently looking into. And I think that goes a little bit into the diverse set of use cases, and we've been focusing on software use case and then maybe very different privacy needs in other areas, or maybe privacy for individuals and privacy in quotes for corporations, where it's more about intellectual property type of stuff and business intelligence kind of things. Yeah, so point taken. Definitely worthwhile. We should bring this up on our meetings and talk about it.
Mike?
Yeah, just wanted to comment quickly. Mike Perrock here. I'm glad Christopher brought up some of the concerns around privacy. I think they're important. I think, though, some important things to note. COSE was designed and does work great with offline and at-rest use cases. That's one of the reasons for detached SIGs. So it works wonderfully there, especially when you're dealing with COSE signatures of large assets, which is often the case in software supply chain. I think it's also important to note, and we'll touch on some of this in the architecture slides later, but the identity question for SCITT is much more around the application level, right? And what's going on there. So it's really, sure, you can go in and abuse this stuff in ways potentially, but I think that's the case for any kind of technology or data store, right? So I think it's something, yes, we should be mindful of, but it's a little bit out of scope.
Yeah, good. Okay, so thanks, Mike. So Ray, I think you're next in the queue.
Yeah, thank you. I forgot to introduce myself. I'm Ray Lutz with Citizens Oversight. And I'd like to speak to the last two, well, I guess the prior two comments regarding SigStore and this identity issue. And I think it's one of the reasons that we are not, we can have, you know, it looks to me like the SCITT layer that's been defined now is will handle the SIG store type of application, but there's a bit of a problem that's they've identified with SIG store, and that it includes very frequently the email address of the user. And I think that's one of the things that could diverge into some of the issues that were just brought up by the speaker regarding Christopher, regarding, you know, human rights and so forth, as to this is not a good idea to add the email address into permanent, you know, immutable storage somewhere. So that's why we really need to look at, not at this layer, but I think it's appropriately taken out of this layer, the identity question, which is very, very, it's a little bit more complex. And so I'm looking at this, in my mind, this low level that doesn't include it, but provides the hooks to use, you know, have identity included in those things. And then the next layer up would be including identity of the company and the product and so forth. And above that, I believe you should not dig into the artifact until after you've covered that next layer up, because the SBOMs have a lot of a whole tree structure inside. Sometimes you'll have many SBOMs related to a product that you have to now have to dig through, and that should be, you know, way above, you know, that's definitely the application layer as soon as you start to dig into an artifact. So so I think that's my comments on those two things. And I do want to say that I'm very sensitive to the human rights and privacy issues, especially within this election area that I'm concerned with. Is one of the key things that we're always worried about. And so, yeah, we've got our antennas up about that, and appreciate the comment. Thank you.
Yeah, thanks, Ray. Cedric, you're next.
Hi, yes, thanks. So I'm Cedric Fournet from Microsoft. I also wanted to briefly comment on two of the recent questions, even if it goes beyond the hackathon. So on privacy, I think there are very interesting, more advanced construction than Merkle trees that provide the same integrity guarantees that is stronger privacy. And I believe that the way we are moving the choice of cryptographic algorithms on Merkle tree or Merkle tree-like algorithms to COSI, and cryptographic agility we are adding for that is going into that direction. So we don't have any algorithm that is specifically about privacy, but I think there is room to define algorithm with additional privacy features if need be. The other comment was on the relationship between SIG-STOR and the SCITT. I think both of them are related to many applications with software supply chains, but the focus is really quite different. So SIG-STOR is primarily about the transparency of signature and signature delegation using OIDC signing for people who cannot maintain a long-term signing key, which is a very important usability feature. While SCITT assumes issuers will be able to sign, possibly using traditional signatures, possibly even using SIG-STOR, that focuses on the transparency of the series of statements related to artifacts on a given supply chain. So the two focuses are quite different, although it seems complementary.
Yeah, great. That's a very great observation. I guess if you look back on my first slide about the three promises, that's quite nicely elucidated what Cedric just said. So we have Mike Ounsworth, and then I think we have the physical queue.
Dick, did you not register yourself in the queue?
I thought it. What do I need to do?
Well, let's hear from Mike Ounsworth, and then you can.
No, it should be click queue or something.
Yeah.
Try it again. You're a pro.
Mike Ellsworth, Entrust. So I'm a tourist here. Please forgive the ignorant question. I could imagine a scenario where we discover the VS Code compiler version X has a Trojan in it, and therefore we want to find and kill with fire any binaries that were built with it. But that also has, huge privacy implications if we're tracking tool chains to that level, developer workstation fingerprinting, all that stuff. I'm curious if that's been discussed here as in scope or explicitly out of scope.
Are DIDs being discussed in this group? Yes, at great length. To speak to your, I think Roy has more inputs on this, and we'll gladly take them. But to speak to the broader question about the size and scale of the challenge, if you find a problem in the compiler, let's sort of squash everything that was compiled by that. It can only be better by having more quickly, automatically verifiable sources of information on that than the opposite. Because if you're getting unverified vexes or whatever else, you still have to validate those, and you're still working in slow time with security engineers. So to some degree, that scale and that proliferation of point-to-point alerts is a thing that we're solving very nicely. But on the DIDs and the rotations and that sort of stuff, yield to Roy.
So this is Roy Williams. The definition of the document formats for software supply chain dealing with the US government are handled by a number of different committees and their definition. The current SBOM format is what's shipping in the package and the ingredients that go into it, excluding the tools. That's this discussion of using that in the EBOM layer, and the EBOMs are not discussed as whether they're going to be public or not, because there's still a lot of complexity around open source tooling and who controls versioning and so forth. The level of detail that we're trying to get to is potentially allowing people to go off and track questionable tools, injecting stuff and making endorsements and claims against products. Those are all sitting on a backbone of what we're talking about here for SCITT. We're just a mechanism for notarizing, holding data and holding relationships. The verticals or the use cases that, as Roman pointed out, that sit on top of it are going to have additional set of capabilities and so forth. It does get into the search capabilities, and some of those are customized by the vertical in which we're in.
Yeah, that's a great point. Again, we are absolutely agnostic to the payload, so we don't care if it's a VEX or a custom CVE or a printout of a fax of handwritten annotations from one security engineer to another. We just make sure that what you see at the one end is what was sent from the other end. The one small caveat to that that is relevant to what you said is this discussion on origin identity. Because we do need to make sure that you get to choose. If you get 3 security alerts, or you get one thing that says, well, I looked at this and it was Cozy Bear, and somebody else sends you one, they say, well, I looked at this and actually it was, it was a software bug. You need to know reasonably well where those statements came from in order to know whether you trust them or not. So there is a tiny overlap just in making sure you have that consistent, reliable origin. But beyond that, we don't go into the application specifics. Okay, let's go.
Am I allowed to talk now?
Yes.
Yeah, but get closer to the microphone.
Like this? Okay. I was super excited to come across this working group and the work that's going on, and read through the charter. I think, as some feedback, it'd be good to understand what's in scope and out of scope, and understanding like who's solving the other problems of like figuring out the DIDs and where the service is going to be. You're doing a hackathon, but I'm kind of wondering like, okay, but what chain did it go to, and what DID was used, and all of that type of stuff. I got up here to talk about the identity aspects. It's a super complicated topic, and you're into a realm of identity that's rarely been worked to standardize because of the temporal aspect. If you want to know who made the statement, say a year ago or 2 years ago, and unlike people, which are the same people, organizations merge, go away, come together, change their name, right? It's a very fluid identity for organizations, and there's not really a global mechanism for that. A D&B number is great in certain systems, but not in other systems. So question is that in scope or out of scope? Because someone's kind of got to figure that out at some point.
I'm wondering whether I should answer or whether
Yeah, I can.
the gentleman in the queue behind you is going to answer anyway.
Yeah.
Yeah, let's just to make, because I currently have my chair hat off, but I should put my chair hat on for a second, just to say, in terms of running the group and the standard and being a good citizen of IETF and everything else, you know, we've managed to make such quick progress largely because we're almost entirely just a collection of conventions over other IETF standards like COSI and CBOR and so on, which is nice and works. Amusingly, towards the end of yesterday, one of the things we decided we need to do in our draft documents is include an out of scope section to answer some of those questions. So we will be doing that and kind of tidying up the document, make it easier for less active participants to consume.
Yeah, but still on the company identification aspect that you, Dick, were asking about, we just had a longer mailing list discussion about exactly that topic, which revealed that this is a complicated area. It's unsurprisingly, but we, like the group, basically asked us to reach out to other folks in the IETF during this meeting and to actually get a better understanding of like who is doing what in that space and what could possibly be reused, because the group has not been chartered to solve that problem, because that would probably exceed our something. But yeah, so numerous technologies or numerous efforts have been mentioned on the list. And yeah, if actually someone here is working in that space and would like to share what they know and what their impression is, obviously it would be great to hear about that. And also on the scope, in scope, out of scope, we probably have to write something down somewhere to explain that better. Also to pile on to what John was talking about at the hackathon, because we have been struggling about this kind of layering issue that also Christopher brought up, like what is done at the application domain outside of what the building blocks are being developed here, and what specifically provide the building blocks and how do they interact. And also Christopher mentioned, like if you don't put certain features in the lower layers, in the building blocks, in the foundational pieces, you can't then fix it at the higher layers. And obviously those are some of the things we want to understand very well in our like approach for layering. So good questions, point taken, Sansa. Yeah.
So Ori Steele, Transmute. You guys have basically covered everything I stood up to say, but I just want to repeat, you know, we have a layered approach here. There are interfaces that help us think about identifiers and identity that come from the other IETF standards we rely on. And I want to emphasize the building blocks component, because the question Mike asked, which was very triggering, requires these higher order applications that make use of these building blocks to consider. And whether or not that's a good idea seems to be not really for us to decide as we try and build these effective building blocks, but obviously we have to keep all of these considerations in mind. And there's a whole section on identity that I will be going through in the future. So if we could keep the identity rocks for when I'm up there, you could throw them at me.
Perfect.
Actually, in the very near future, you will
yes
talk about this.
So if you don't have rocks, now is the time to go and get one. So yeah, so I kind of consciously gone into the extra conversation time because it seemed like a good conversation, but I think I'm kind of well over the slot by now. Yep. So if we could just have Dick Hart is in the queue.
No,
so.
he spoke already. He didn't pull himself
didn't
off.
Oh, sorry, Dick, you didn't come out again. Right. Okay, good. So just to say, I think we've lost the other deck, but just to say, you know, outcomes. Yay, you know, we got the application working and it's cool, but there is, you know, the reward for success is more work. And the more work that we got was to recognize that actually a lot of the issues we were finding with working out the layering problems, we think we can fix that by being much more careful, let's say diligent, about how we define what a feed really is. I think we all have an intuitive sense of what a feed is, but all of those senses are slightly different. So we need to actually write it down and work out some structure for those. And yeah, so that'll be the next phase of work. And the other thing is just to say I didn't commit some of this stuff to the open source repo, but I will do in the next couple of weeks so that it's all, again, out there, interoperable. And if somebody else wants to make it into an implementation, then they can do. So good, thanks very much. And we'll move to the next thing.
Yeah. And if someone, thank you, John. If someone is interested, from those who weren't attending the hackathon already anyway, to see sort of to set up their own local kind of demo, come to us and we'll work something out. Maybe we provide a reasonably good description on how to get there, just to get a sort of look and feel. Okay, architecture. Who's up first? Mike, cool.
Thanks, Hannes. Hopefully that microphone's pointing roughly the right direction, but
Or you can also take it up.
I can. Yeah, I hate holding those things. I like walking around and yelling at people, but IETF's not great at that because we don't have the little clip-ins. Next slide. I got volunteered for this thanks to Hank, so don't show up early is my advice to folks for next year. Let's roll to the first slide here, and we'll talk a bit about SCITT. So, rolling into 117, couple of big concerns. I mean, one obviously is kind of opening doors that we can't close or can never be solved. And I think the other one is going down this path that leads us to dead ends. And some of us have been out on excursions with some of the folks involved in this working group and found dead ends. So that's why we have photos of that. But I think probably more importantly, despite the stickier conversations, is things do feel like they're coalescing, right? We've been able to use the emulator pretty clearly in a lot of different ways. We're seeing interoperable stuff in a lot of different areas, which is cool. Like this is actually getting to something almost usable. And I think there's kind of a key area, couple of key areas that we're going to highlight today as we dive in. Next slide, Hannes. The key theme to bear in mind as we proceed through the architecture discussion today is that SCITT will not be and will never be the curator of 1,000 different semantics. There are people that go after all sorts of stuff and want to define every detail of what does it mean within an application payload, et cetera. We're not going down that path. This is very payload agnostic, very, very intentionally. Next slide. So for kind of the recapper, for folks that are new to SCITT and folks that have not seen that, we're really after kind of setting up kind of this core data layer, right? How do we go through and put stuff into a transparency log, ledger, whatever you want to call it, right? I think we're finally standardized some vocabulary now in the drafts, but things have moved around a bit. But it's really around how do I know what software, and what components in that software exist, so that when there's a vulnerability, I can backtrack that stuff and identify it, cleanly pin it down, get it replaced, and move on to the next real world problem. The nice thing, and I think there's a good call out, right? Portability, implementations, these are good things. But the good news call out point that I'll quote right off the slide, if we need semantic interoperability of the data that is going in and out of these payloads, there's already vocabularies that handle a lot of this stuff. There's already well-defined concepts and a lot of times regulatory stuff that tells us for certain cases what that data structure needs to be, or at least what fields exactly need to be there. And we have to abide by that. That's the world we live in. Next slide. So with that, couple of things in activity going on 117. So couple of spec topics. The identity thing's going to come up again and again. The feeds thing, probably more importantly, I lovingly get to hand over to Ori in just a slide or two so he can introduce that topic for us all to talk about. It's going to be an issue. We've got to figure out, is this a URL? Is it not? Is it a CRI? There are some nice ways of doing this. There are some things that are less nice ways of doing this. None of them are perfect, but we need to figure out a compromise. That's the joy of standards. Also at 117 so far, we've got some great code proof, right? Dick did some great work on this stuff. We've seen some other things. I was able to run some tests that'll probably show at 118 around machine learning assets and things going in and out. That stuff's working really, really well. This is nice. This is cool. So I think probably more importantly, there's another area that we've seen the beginnings of, thanks to John. Coming from a search heuristics, machine learning background, the indexing side is coming along really cool too. Like you could do some nifty stuff, especially when we look at embeddings. So we're enabling a lot of capabilities off of this stuff. Next slide. So a couple of 3 slides and then I'm handing it to Ori. So recent updates, if you have not been following drafts, use cases. This stuff got refined a bit. Basically the focus is around like core terminology of append-only logs. That's really what we're dealing with. We're really focused on producers and consumers of software. And then we cleaned up the use case placeholders, right? We cleaned up some areas and dropped in actual use cases. I think my opinion, I think a lot of opinion of a lot of folks in the group is that the use cases seem to have pretty good consensus. At some point, hopefully during this meeting today, we go ahead and figure out if we could take this to a working group last call and move it along. So
maybe we can have 2 reviewers to sort of go through it. We obviously looked at it, but we want to have 2 ideally non-involved people to actually tell us on whether they think this is readable.
Yeah.
And then we would, if they say yes, we would issue a working group last call. So do I get 2 hands up? Some people are now disappearing. Okay, I see Dick.
Awesome.
Also sees. What's the time frame? Next month.
Yeah.
Oh, okay. So so I see Dick. Hold on. No.
Well, that would be nice. Thing is that you are volunteering to become the blocking factor. So
yeah.
But that's better than not volunteering.
Dennis, you can put my name down too. This is Elliot.
Thank you, Elliot.
Asking for 2 and getting 4 is always a wonderful thing, especially when they're all folks that actually can read this stuff and tell us if we're idiots or not, which oftentimes is the case, at least when I'm involved. So next slide, please. Channeling my inner Ori here. Couple of other things going on from the overall advancement, especially in the architecture stuff, and we'll see some beginnings of some drafts we'll look at later. But I think key thing is text on registration policies is significantly cleaned up. This is actually readable now. There's still some open questions, right? There's a current baseline that stuff coming in registration wise can be gate kept by the issuer. That is what it is, right? We gotta figure out, is that sufficient or not? The other thing around some of the transparency service items is that implementation is completely up to the provider. That's probably not a bad thing, but it's an open question, right? So it's something we have to go in and resolve. So feedback on these items, especially on the list, especially from folks that are now looking at this work coming from other areas of software engineering, would be excellent. Next slide. So the third piece, and this is kind of part of the key thing that lets SCITT work, which is this whole notion of receipts, right? So we now have a SCITT receipt is now an actual profile of a signed inclusion proof, right? So we've got some nice things to go point at. So thank you, Ori and Hank, primarily for doing all the hard lifting here. But we basically have a nice clean structure that is the receipt structure you can see there. Has a version number, TS identifier, and a proof, which is a signed Merkle tree proof. Cool, nifty. There are some additional protected header attributes that are going to be coming in. So we might look at some of that, I believe, in some of the later slides, but that's just an area. Definitely dig through the architecture side. If you're looking at what's coming back when you get a receipt after you've checked something in, pay attention to that stuff, especially if you're then taking those receipts back and indexing on your side or handing to third party, right? We have to hand over to third party a lot of times in security reviews. So it's just something to be aware of. Next slide, and I believe at this point, Ori's up. Oh, we got one more. This is the additional header attributes. We did add this slide up. So a couple of things to be aware of. The SCITT receipt version did transparency service, the actual version of the actual ID pointing, public key for that transparency service. That's a key thing. Additional policy information. I think that's still being beat around, but we've got a place for it. Critical headers, key ID, and are we linked back to an X509 searching? And I think these are all good things. So just be aware, go plug in through the definitions of that stuff in the architecture deck, open issues there on GitHub, or file comments back if we need to clarify or improve any of those items. So now with that, I'll hand it to Ori.
Actually, can you leave that up one more second?
Sure.
All right. I'm Ori Steele from Transmute. We're going to leave the world of protected header parameters that are interesting for digital identity and identifiers. And we're going to talk about some of the challenging topics in this space that touch on how to use identifiers for indexing. What are some of the guaranteed interoperability points that might be available to services that are consuming transparent statements? And the reason I asked for this slide to be left up is a lot of identity identifier information is in the protected header with registered claim names. And so this is going to be a topic that we're about to dive into as we start to look at some of the identity issues in the space. But I want to be very clear again, we are relying on other IETF work for identity things. We're not doing identity in SCITT, but we have to understand identifiers and identity issues that come from the broader ecosystem that we are a part of. Next slide. All right. I think this may have actually been one more for you, Mike, but where are APIs going? We are breaking out from our architecture some of our API specification work. The interoperability client that you've heard mentioned is essentially a client-side software tool that communicates to a back-end API and that helps us establish some minimal interoperability around the envelope formats and back-end transparency services that might use many independent technologies to implement the underlying ledger technology that supports the proofs that are necessary for SCITT. Keep an eye on this. This is going to be evolving over the next couple months as we start to focus our attention on the API and interfaces for interoperability and exchange. Next slide. All right. Yes. So you've heard this word feed several times. And here we are with we are not the curators of 1,000 semantics statement again. It's important to say that up front for feeds because they become an entry point to so many interesting conversations. It's very easy to get lost. Essentially, I like to think of feeds as a lens into the supply chain value network hypergraph. There are certain questions you have about supply chain infrastructure, and feeds are a topic that allows you to gather information that's relevant to a question that you have. So that's basically most of what we know about feeds today. They encode an interest for a party, and there's all of these different interesting content types that might be associated to a feed topic. So we think about vulnerability disclosures and vulnerabilities on software artifacts, and SBOM is a bridging technology that helps us start with one artifact and start to discover interesting statements about that artifact from other pieces, other artifacts like the VRF, the NVD, Stix, Vex, Cyclone DX, these technologies. If you have a transparency service that's included many different content types regarding a software supply chain, a feed can express a common topic or collection of resources that help answer those kinds of questions. Bottom point on linked data is not out of scope, but is not a target. It's worth, I don't know how much folks know about linked data and graphs and these kinds of systems, but there's a lot of reasoning and logic that kind of comes from graph analysis when you are looking at the supply chain ecosystem. You're tracing relationships between artifacts, content identifiers, and there's a lot of value in experience from that space, but it's also a dangerous infinite pit, and we don't want to fall into it forever if we can stay focused on our software security mission objective. Next slide. So this is where I was planning to start. Identity. That's okay. So identity. Why are we going to talk about identity? Even though I've just spent all this time talking about how we're not about identity. We have issuers. These are organizations who create an artifact. In the software supply chain scenario, artifacts are like an abstract concept. Be like a binary. It could be statements about a binary or files, or printed out faxes of PDFs that have been scanned and rescanned and PDF'd and rescanned. And artifacts are things that come from organizations, and you want to know who are those organizations, what identifiers are present for those organizations. Artifacts, these are these products produced over time, statements about products produced over time. And the challenge in this space is, I want these artifacts represent intelligence sources. I want confidence that those intelligence sources haven't been tampered with in transit as they've moved through a supply chain. So I care about cryptographic keys that verify the authenticity and integrity of artifacts. But then I also care about the identity associated with those keys. So I want to know, it's not just enough to verify a signature. I need to have some reason to believe that that public key is the private key is managed properly, associated with the right identities, et cetera. So we get into these challenges with identity around how are keys bound to identifiers over time, how are keys represented, key formats, JSON web keys, X509 certs, cozy key, and how are keys discovered for those identifiers. Next slide. So we're going to start this conversation on identifiers, and here at the top you can see this sort of left to right pairing. This is how I like to think about this particular problem. The left-hand side are the registered claim names that are identifiers for looking up and discovering keys. And these are identifiers you see in existing envelope formats today. So you see a key identifier, it's supposed to help you discover a key. You see X5U, it's supposed to help you discover a certificate chain. How you actually go from a URL to a resource that you can use to verify a signature is done in many different ways. OpenID Connect is going to do it one way. Other systems are going to build new ways of interpreting these parameters. And this decision point at the bottom is important. Like, we will enable interoperability with these existing identity ecosystem technologies via these URIs. And that reason we're doing that is the envelopes have these boxes where you can put a URI, and it's going to be understood as a URI. And so this is an important part. Like, we're not inventing anything here. We're just using the building blocks we have from Cozy. We're not going to open a can of worms that is defining identity in SCITT, but we will Hank. we will for sure support existing envelope formats that support identity representation and identifiers. Identity representation identifiers are different things. They're very, very commonly conflated. And you're going to see some slides soon that are going to hopefully get into that. I didn't talk about the right-hand side that much of the top examples, but those are media types that represent key formats. At the fundamental level here, we're talking about an identifier that you can use to get to a key format that you understand, so you can verify the integrity of a signature or a proof. And so just clear your mind and think about an identifier that brings you to a media type that represents a key that you can use to verify something. And the rest, well, we're about to get into it. Next slide. So issuers, you've heard a a few times, you know, organizations are producing software artifacts. They're also making signed statements about those software artifacts or other software artifacts. The ISS field is another header parameter that we inherit from using COSI. And I want to be clear about this ISS field, the issuer concept. Identifiers for issuer like vendor0.example or vendor1.example, they could be both owned by owner.example, and that might change over time. So we already had this question come up. What happens when two software providers that are competing both get bought by another vendor, and then that vendor gets bought by another vendor in a different country, and then that vendor gets bought by another vendor in a different country? These legal entities and the concept of ownership are different than the concept of stable identifiers you can use to obtain key material. And if you're interested in like traversing that graph of relationship between identifiers over time and legal entities, you might be interested in signed claims that help establish relationships between identifiers. And there are existing systems out there that work in this space. And so at the bottom, you can see a decentralized identifier representing a particular company and a URL representing that same company in a different format. These relationships between identifiers are part of how you establish the organizational structure that is extractable from integrity protected artifacts. So this is not really our space, but we're acknowledging that in these signed artifacts, you're going to have claims like this. And, you know, because this question keeps coming up, we're trying to explain that this isn't really our business, but these identifiers are going to keep showing up in artifacts in various places. And in particular, if you start digging into the payload, you might find PII or other sensitive information in the payload. And what we're making transparent is not the payload in our building blocks. And this is a point of like a lot of confusion. So we want to, you know, make it clear. We make signed statements transparent. If the payload is stored or not stored, that is application layer above our building block. Please.
Dick Hart, again, ARN identifiers. A challenge I see you have is that when the ISS claim was created, it was in a context of how do I go and verify a token that in the context wasn't super long lived compared to these potential statements that are, you know, potentially years of length.
Yeah.
And so I think because the use case of what you're doing in SCITT is different than how these types of identifiers came up, I think you need a double click down as to how are you going to, like, it needs to be thought through. I mean, we're doing engineering here, and that's going to be a problem that we need to engineer and think about, aren't it? As a statement. I have a question from your previous slide. If you want, if you can go back.
Of course I want. This one?
Yes. So in almost all the use cases I've seen for a KID, it's just some random number, right? That is associated with a bundle that I got by some discovery process from the issuer. And so I'm kind of confused on this slide because it's like discovering identifiers, but a discovery like your order is kind of backwards. I would start with the issuer, and then I would get a group of kids, and then I would go and figure out which one was used to sign this thing.
Yeah.
And of course, in typical applications, right, those get rotated every once in a while. And so the kid that was used to sign it 2 years ago isn't around anymore for you to verify the signature. I mean, there's just a whole bunch of gotchas when I think of how I've built and deployed a bunch of stuff that's using these things, as to how they actually map into the use case that you have now, which is not how these things were designed.
Yep.
Yeah.
So just briefly, the HOSI world, which is JSON object signing encryption, and COSI have sort of similar ancestry and similar identifiers, but differing degrees of support in header parameters. ISS, you can't even include it in a COSI header parameter yet. There's draft work. There's work that establishes that in the COSI working group that's still ongoing. So presence of header parameters you might expect from HOSI, you don't always actually guarantee that you can use those in COSI. And the rest of my slides address some of the questions you're raising. So hopefully they'll be better. Yeah, please.
I'm standing up here trying to figure out how to make this understandable. But if you, the next slide, so if you like take the next slide.
Next slide.
Yeah. So I agree with the approach. I think it's probably the only approach you can take. But beware that every time you introduce one of these name to key mapping problems, you also inflate the attack surface. And I was thinking a little bit about sort of the duality of the way certificate transparency works together with the CAA record. That allows the CAA record is sort of an important complement to the certificate transparency in the sense that it allows the consumer of a certificate service to state, you know, these are my suppliers, right? And I'm thinking maybe you want something like that in order to make it sort of less likely that one of these name to key binding, and you're going to probably introduce many of them, are less hard to attack, right?
Yeah, I agree with everything you said. Hopefully some of the next slides dig into this better. Next slide. So we've already started talking about identity providers. When we start talking about discovering keys for an issuer, and I'm backing up for a second, you know, one of the reasons we're here to have this conversation is to sort of stop talking about identity and SCITT by talking about identity once together here and on the mailing list. We've been talking a lot about it. There's a certain amount of sort of background in the space that you need to have. And Dick's definitely got a lot of experience in that space, and once you understand that these technologies and these other IETF building blocks exist, you might not ask for SCITT to go invent another view of them. So I'm repeating information here, not to say this is work that we're doing, to say this is work that's already been done and we're trying to rely on it and support it. And this is me repeating myself again from the beginning. But essentially, transparency services can leverage identity providers to understand the issuer and subject identifiers. Identity assertions establish relationships between identifiers and names and keys. And there are lots of examples of this in the software supply chain and identity ecosystems. And ID tokens from OpenID Connect are one example. Licenses for barcodes is another example. Developer certificates in app stores is another example. There are lots of these kinds of ecosystem components, and because they exist in software supply chain today, we are required to understand what making parts of them transparent means. That doesn't mean we have to reinvent them or say that they're bad, or, you know, but we have to understand that these kinds of, some pieces of this information are going to make their way into transparency services, and we need to be cautious about how that happens. Next slide. So this is a description of what a URL is, and it's borrowed from a GS1 standard called Digital Link, which is related to expressing URLs as QR codes. And so we've been talking about these feed concepts, and one of the things that we've been saying a lot is that a feed is like a URL or URI or a CURI. So in other words, it's a structured identifier. This isn't an opaque string. This is a structured identifier. And so the first question is, if it's a structured identifier that's a URL or URI or a CURI, what are the components that make up that identifier? And how can we use those components to express properties that we can use to lens into the supply chain hypergraph to find the interesting pieces that we're looking for in topics that are relevant to a security question we might have about that supply chain. This is an overview, again, of what a URI URL is. I'm not going to read to you each of these components, but some of these pieces have been applied consistently over and over and over again, and it's kind of worth just thinking about in the software supply chain scenario, whether, you know, for example, the path component, you can see a directory structure. And before we started talking about how SBOMs have this tree structure. So if you're building a feed, you might want to think about that because you've got tree structure showing up in two places. Is this a interoperability point for feeds, or is it not? Like, if we say we know a feed is a URL and we know the path can represent tree structures, well, maybe there's interoperability there that every transparency service could leverage. Maybe we think that that's a bad idea and we want the issuer to always be able to determine how they're going to do that mapping. And so one issuer might use the path component for one thing, and another issuer might use the path component for another. Is that flexibility we want, or is that destroying an interoperability option that might help two vendors identify they're talking about the same piece in a consistent way? Don't have the answers. I'm just saying URLs and URIs exist, and they're relevant to feeds. I see Elliot is on the queue.
Hey, thanks. Just a cautionary note about this slide and your question. Hannes may remember, or other people in the room may remember, there is a BCP that states, Mark Nottingham wrote it, and it was, the draft was called "Get Off My Lawn." So be careful about what you are standardizing in other people's namespaces, particularly on a web server. That's the basic concern that Mark has. So I won't say more now. It's just a cautionary comment because the document, if it proposes to do that and it gets the IESG, it'll get bounced back.
Thank you. Yes. And in particular, you know, URIs with web origins and host names that are domains versus other structured identifiers, URNs, what working group's definition of what a URL is. Like, we need to be very cautious if we say that a feed has the structure, and yeah, I agree with everything you said.
I'll just add one comment to that, which is, and Mark gives you an out, right? Which is, if you really want to standardize this, there's the .well-known URI, for instance, that you can take advantage of if you see value in doing so as a community.
Thank you. I think that's enough of a recap of what URLs are. Next slide. So we just have, maybe you have like a really fuzzy feeling about what a feed is now. It's this structured identifier. It helps you lens into interesting questions about the supply chain graph. This slide is meant to help evolve that feeling over time. And I want to be clear, like, these examples that we're showing here are not like, this isn't us saying this is what it should be. This is to try and communicate the concept. And like you saw in the header parameter examples, that the issuer, the transparency service, and the feed can all be, header parameters that might sit next to each other. The fact that they're next to each other relates them. You can also think about turning that side-by-side piece into a deeper hierarchical relationship. So if we say the transparency service and its registration policy control what signed statements with feeds are going to be made transparent, the transparency service is a natural route over feeds that will be present in it. So this is a logical thing that I'm doing here with the transparency identifier. It's just to say the transparency service decides what it's going to make transparent, and therefore it's the beginning of a structure of a feed, even if it's not literally encoded in the feed identifier. This is a confusing part of this slide, and I apologize for that. The goal is to say a transparency service knows about feeds that it'll accept. It might know about issuers that it'll accept signed statements from. And the most basic concept related to that is about what public keys are going to be bound to those issuers, those identifiers. When you think about this, it's not a URL, but it's sort of hierarchical structure at the top. And it's an identifier for a collection of public keys for an issuer over time. And we know about content types that are going to be relevant to answering that question. So we could ask, can I get a feed of keys for an issuer over time? And is that key transparency if the content type is a well-known key content type? You might need to do that, especially in the case you were talking about where you're rolling keys often from an issuer. You might also not want to, well, you should be careful using OpenID Connect for things that it wasn't built for. So I don't want to say much more about it other than like we have identifiers that the transparency service is kind of the natural authority on whether that structure is going to be acceptable or not. And those identifiers in turn include further structures that might relate issuers to other relationships that are to the issuer, such as the keys that are related to the issuer, or the products that the organization the issuer represents produces in one country and produces in another country, and the subcomponents of those products. And in order to make sense of those signed statements about this sort of complicated identifier space, you might want to witness these public keys that the issuer is using for these signed statements over time. So you can say, you know, if an auditor comes, yes, I have that signed statement, here's the inclusion proof, but also here's the key that I verified that signed statement with at the time I made that statement transparent. This is a thing that you can do just by, because you're going to have that public key when you verify at the registration policy layer, which we've not talked about this IETF, which I'm grateful for. But if you're confused about it, please read the architecture. This is an important topic, especially over time, like you were saying, and especially in a long-lived environment. Just knowing that this key was used for this identifier at this point 10 years ago, I might need some other information to go along with that for certain scenarios. So next slide. So I did keys first because the keys are verifying the signed statements. Now we can think about the products. So the organization's producing software artifacts. Those are products that might be made of other products. They may have deeply rich, very confusing subcomponent structures. And one of the things we looked at during the hackathon was the CPE identifier structure. I regret choosing orange. I don't know if you can read this. But it has a feed-like structure in it. So someone has encountered some version of this problem before. You've got the vendor, actually the asterisk here before OpenSSL is saying like any entity distributing OpenSSL versions that I don't even know about. So these wildcards have a meaning in this structured identifier, sort of like a URN. It has a kind of a concept of a organization product version. So that's like a sort of primitive feed concept right there built into this particular identifier. And then at the bottom is wonderful XSD regular expression for parsing these things and thinking about them. And one of the questions we asked at the hackathon that really truly hurt me was, you know, is a feed like the CPE identifier, or is it like, how are these concepts related? And if I'm interested in endorsements over time from various different vendors about the same product, what is the sort of space of the URI, CURI identifier space that helps me answer that question? That's a information representation problem in a structured identifier, which is a thing that you can spend a lot of time thinking about. I think I want to go to the next slide. So in the interest of motivating some thoughts around that, this is a slide that is borrowed from EPCIS, which is a standard that is sort of related to supply chain information. And it's really, the point I want to make on this slide is that we're doing software supply chain work, and there's a lot of physical supply chain work that has a lot of lessons that we should be paying attention to. Like they've had similar problems of provenance. They've had similar problems of attacks on physical supply chain that look very similar to attacks on software supply chain. That there's a lot of overlap there in terms of defense in depth, security analysis, you know, modeling, threat modeling, et cetera. And so EPCIS has some interesting ideas for us to be considering along the way. And the point here is that you can think about feeds as being at the beginning or the end of these higher order concept of workflows. We've all seen barcodes on like everything these days. You all scanned this blue sheet. That was the beginning of a process, an interaction between an authenticated user and identifier. And it was part of a tracking experience that leads to IETF being able to tell whether we're being successful at SCITT or not. You all, when you scan this QR code as an authenticated user, you help the IETF realize that SCITT is, has at least some attendees. Like, this is a good thing. There are more complicated workflows that aren't just people who are authenticated scanning an identifier and registering themselves in a database. But there are a lot of simple workflows that kind of look like that, like the one that you've participated in. So you think about this identifier, this QR code that you scanned. It's a structured identifier and you interacted with it. And then at the end, there's this feed of all of the people who interacted with this QR code. So you could create a URL for the collection of people that scanned the QR code, or you can create a URL for just the QR code. So feeds can be at either side of this picture, and there can be very complicated processing in between. But the business problem that IETF has for feeds is like they want to know how many people came to the session. They're interested in the feed that comes from all of the people scanning the QR code, that feed at the top of this picture. But in order to enable that, they created this QR code at the bottom of the picture that you were all scanning as authenticated users to participate in this process. The details in the center are probably good to get off the screen before people get too lost in them. But this concept of like where are feeds in the software supply chain, and is a QR code a thing that I slap on a product or like a car or a tank, and it tells me the complete history and provenance when I'm authenticated, versus a feed is a thing that I scan, and by scanning it, I am altering the data structure that that feed represents. So one of the things that we talked about at the hackathon that also hurt my mind a lot was thinking about feeds as a query that updates when the signed statement that it includes is registered. It's sort of a self-updating identifier in some sense. Feeds are really painful to think about. Next slide.
There's no more slide, but I have a question.
Yeah.
So on page 3, no.
There's 3 definition now.
Yeah. There's currently the definition or the text on feed is pretty small. It says it's an identifier chosen by the issuer for the artifact. And then it defines a claim which says it's a string. How do you want to change it based on what you described now?
So I think the proposal is we want it not to be a string. We're not really sure what structure we want beyond that, but we're sure that letting people call it a string is probably going to not be as helpful as giving them some structural requirement. And then the other part that we're interested in is, actually, could you go back to the URL, Adam, breakdown of what a URL is? The other question is, okay, so if we say it's a URL or a URI, are there parts of this structure that we think are interoperability targets for all transparency services that all issuers should understand? This gets back to the point about these header parameters, like why did we create ISS? Like what was the purpose of registering that claim? And can we register parts of this URI space in a way that issuers can exploit consistently, to be interpreted consistently, so that they can communicate more effectively with each other? I don't know the answer to that, but if we say it's a URL, the next part of this is, are there any structures inside of a URL that will always be interpreted the same way by issuers, and how do we communicate that?
Okay. Mike. Actually, you and oh,
Yeah, well,
sorry.
mine's short, so only Mike probably smarter than me, so he'll actually add some content. I'm just going to make a comment, but I do have quite a lot of experience of this specific question of how those things are done. And back in the early days, when I was very dead set on things like NFTs, or very not the monkey type, but the ERC 721 type. It is very appealing to have this idea that a feed is somehow the calculated accumulation of all of its sub-experiences. For certain use cases, this works brilliantly well, and even for sort of poetic literary use cases, it works brilliantly well. If you think of your personal identity, it is only the collection of your experiences to date, or at least the ones you remember. So it's a great model for some use cases. It is a terrible model for others, because if you've got if you want to look for things like the non-equivocation promise and you've got a receipt in your hand, what is convenient, and actually what I did yesterday to make the thing work, what is very convenient is to say, well, if I've got a receipt from a feed, so I'm dealing with an authentic artifact, that feed should tell me every other statement about this artifact, so I can make a completely informed decision. And in those cases, you don't want it to mutate, or at least you don't want the identifier to mutate. So we need to, it's another question of this sort of use case specificity that we need to be super careful of.
Yeah, thanks. And John, I think you hit on some big things, because I think we have both use cases to deal with here in the scenario of SCITT, and so we need to be very mindful of that. I think one of the dangers is that if we don't provide at least a path to interoperability around feeds, we will wind up with vendor A, vendor B, vendor C, vendor D, all doing things completely differently, and then analysis becomes useless. Literally, it just becomes so much noise that we can't go through and identify patterns in a clear way, much less actually mitigate an issue once it's been identified, and that's kind of what we're here for. There are some options. We can also do things like say, yep, we're going to keep it a string, or maybe say it's a string or a CRI, right? Going down, or better yet, just go down the COSE path, right? If we can keep doing that. But there's some options there, but then in a separate draft, perhaps define some mechanisms by which here are some approaches we could take for feeds so that they are interoperable between vendors. And that could be quite a helpful path to go. So.
All right, throw the rocks now.
Oh, no rocks. Dick Hart again. I think what was who brought up the comment about, stay off my lawn? I think you want to let people be able to go and have stuff that's going to map to what they want to do. The term feed is, I think I know what we're talking about, but I don't, because I thought we did, and then Anna's read the definitions, like, well, now I'm super confused. Because when I hear the word feed, I think RSS, right? And a whole bunch of meanings come to mind around RSS, which then has some cautionary tales. Having recently tried to find the RSS feeds for a whole bunch of news sites and realizing there is zero standardization around how do you do that. Like, you can't, right? Like, we literally went by hand and did them all. And to the previous person's comment, right? Like, I've written connectors to almost all the issuers on the internet today, and everyone is its own frickin' unique snowflake around how it works, right? And so if we really want interop, right, which I think is super important for this work, you're going to need to be very opinionated around some things so that stuff just works and everybody knows how it works, as opposed to letting people do whatever they want to do.
Thank you.
Shigeya Suzuki, Keio University. I have somewhat knowledgeable about the EPCIS, and as I remember, the focus on the use of the EPCIS is kind of the live feed. So it is trying to receive information from the various RFID data information towards the EPCIS. Then EPCIS feeds lively to the applications. So my understanding of the SCITT is that not the live feed. That was my impression. But what is the use case of the SCITT to be? I mean, is it used as a live to some of the application to receive live feed or
Yeah.
continuously query?
Yep. So it's a building block,
Uh-huh.
and the applications that are built on top of it might implement real-time pub sub for vulnerabilities on software that's known to be in a specific hardware component. And Mike Onsworth's awesome question, and all of the issues that come up with it are at that higher order application layer. But feeds is going to be one of those things that sort of similar to Christopher's comment, like if there isn't some integration interoperability point that's consistently leverageable, some of these higher order applications will not be able to rely on it. So,
okay, thank you.
Hi, Dave Holtmeyer. So Mark Nottingham also worked on something called Atom, which was supposed to be a successor to RSS. Yeah. And the way Atom actually handles feeds is it uses relationships to declare like how you go to a next page, how you submit a new entry. It's extensible in the way that you can augment the metadata for the feed to basically describe how you navigate through the feed or how you navigate into the feed. Maybe using something like that here is a way to make these URLs more opaque, but to still provide the actions that are needed to, to interact with the feed in meaningful ways.
Yeah, I agree with everything you're saying. And the comment about linked data and curation of 1,000 semantics comes to mind. Like, it's hard to look at this problem and not reach for some of these technologies that have applied to it, this kind of thing before.
Hey, this is Ben Gehring from Protocol Labs. I basically just want to plus one the idea for using URLs for this, and basically just, I like it specifically, I like the idea of structuring like the path information. At work, we do this thing called UCANs, which can represent certificates. And so that path information, like because we encode those sometimes as this thing called IPLD, that path information can kind of compose with that to select individual elements of the certificate, because like the certificate itself is represented as a Merkle tree. So just commenting plus one on like URLs and path information.
Thank you. So just one more comment is we didn't talk about the cozy Merkle proof stuff and verifiable data structures and new types of proofs on verifiable data structures. But later today at the cozy session, there'll be the draft that covers those cryptographic details. If you're interested in that, please come to the cozy session to learn more. But that's part of why you don't see it in this presentation outside of like a few pointers that it exists.
Wait. So you talked a lot about identity. What is in the document right now is there are two aspects. One is the issuer needs to be identified. It signs the statements. And there the sort of recommended way is to use the DIT web method. And then you also have the transparency service side, which kind of loosely suggests that should also use the same technique, but it's a little bit dances around the issue. Maybe that needs to be fixed, or at least decided on whether it's the same or not. The DIT web is conceptually quite simple, I would say, but in the discussion that you presented, or the topic that you presented today, how would you change what is currently in the document to sort of accommodate that thinking?
So we wrote a lot of text on identity in the architecture document because we kept having people bring up questions of identity. Christina pointed out that this was maybe a mistake and that we should just reference the existing specifications and write less about identity, like recap less about identity. I agree with that. And I hope that after this IETF and after this long discussion of identity with all of you, we can remove some of this lots of text that we've got in our document, and some of it might go to the REST API document. Some of it might just go away and then be referenced directly inline references. You asked questions about DIDWeb. I think the identifier security scheme for the transparency service and the identifier security scheme for the issuers don't necessarily have to be the same. You could have a mix. That's your transparency services policy is what to describe, like you get to decide that, but the interoperability and interpretation of those things needs to be consistent, and it needs to support the identifier schemes that are securing software supply chains today.
Just a quick add-on to that. But I think from a purpose of interoperability, it should have one sort of like recommended way to do things rather than, so it's obviously something we should discuss, but
Hank, you want to?
But yeah, maybe we can pile onto that and let Mike jump.
Yeah, I was going to say with identities for folks publishing software, right? There's a couple properties we need for that. We probably need a common data model for exchanging that. DID may provide us that, right? DIDWebs being one simple example of that. But we also need a history of public keys, right? If you go in and rotate, right, we need the ability to go back and say, well, who, as a publisher, what have you done previously, right, prior to that breach, or what other thing changed, right? Maybe it was just a time-based policy that forced rotation for some weird reason, right? So there are other properties we need to account for. We also need to account for the fact that, especially in the open source world, we tend to have oftentimes individuals or repos, right? Going through and publishing, and maybe we're tracking at the pull request level. Maybe we're not for certain things. So there are things like that we need to account for that I'm not sure that DIDWeb covers perfectly. There are a number of us looking at that, including one of the editors of the DID working group, and I have been talking about that lately. So we might put some thoughts together in a draft, obviously consulting with Ori, and say, hey, here's an idea of some ways that we can go beat it up. But I don't think DIDWeb is perfect for our use cases as it stands today.
So as one of the few people that gave Ori the headache yesterday. So that the gaps that we see with DID web and DID mechanisms led to the question that Ori was trying to solve yesterday, which is there information we have to plumb out of the notarization system and an overview system to allow us to do some of the complex things we need? In cases that I gave him here is 2 auditors are approved by your organization. I want to know if any of them have given me an endorsement on a product. It's not the owner of the product, it's auditors of the product. And they have the same problem that Mike was talking about. They just rolled their keys. And how do you build together that document of the identities they possibly used to efficiently come back with the last statements of support or negative support for a product? And that's what's leading to this discussion of, is there something we have to do to staple it together, or do we have to come at it a different way? And unfortunately, I didn't give Ori aspirin at the end of it.
Bob Moskowitz, sorry I'm not in the queue, but my phone keeps on dropping the connection. I have been identity discussions for at least 25 years. Actually, probably back to when I was 11 years old, which is another story. But perhaps avoiding this problem of solving too many levels of indirection, we can go to classes of identities. Are we talking about a person? Are we talking about an organization? Are we talking about software? Are we talking about a device? And just go to some general classifications of identities and then solutions for those classes. As just was mentioned about auditors, is it the physical auditor who is doing it, or is it the auditing company that is the important thing that we need to have in here? So if we instead step back, as you've tried to do, try to step back from this, but step back and just go to a generalization of classes of these things, and then let the chaos follow the classes because it will be chaos. And one of the things I'm very concerned about is that you have so much in there and somebody looks at this thing and say, how am I supposed to figure out to trace this identity back? Is there enough information in this thing for to identify the person who did this? We recently had FAA pull back a declaration of compliance for remote ID from a JDL drone, and JDL says that person was dismissed from the company in relation with that declaration of compliance being called back, and we have no further information about it. But is it that person's fault that person stepped out of bounds, or is he just a scapegoat? We don't know. But that's just another example of this whole problem space that we're dealing with. And like I said, I've lived this for at least 25 years professionally and probably over 60 years. That's not, and that's all I have. That's too much, saying too much.
Just one more comment on the idea of scapegoats and developers. You know, was mentioned earlier, there are developers who their personal identity gets encoded in software artifacts as they produce those artifacts on behalf of an organization, and it can cause real problems.
We just had that discussion before.
Exactly.
About the privacy issues of that.
And that's why, you know, we really want these payloads to be opaque, and we really want to be careful about indexing into that kind of information. But we shouldn't be naive enough to believe that those kinds of identifiers don't leak into these assets every now and then.
Yeah.
So,
And am I Bob? Am I Robert? Am I Ruthie? What is my identity? Depends on the domain of applicability.
Yeah. If I can just respond very quickly in the interest of getting our work items finished. Well, so we are very short of time as well, but I like that's a great suggestion. The classes of identity helps us on one side, and the responsibility of each building block. If you put those two things together, what we want to say is the appropriate level of identity has to enter the building block and absolutely nothing more. There are because otherwise, if we try to solve the messy chaos, as it was said, it will never, ever get solved. The important thing for us here is to make sure that the building blocks are coherent and consistent, that they don't disallow things. Because in the case of critical software, in my former life, it is absolutely essential that you know when you receive a software payload that the person who reviewed it is a properly qualified, identified expert who is able to check that this vehicle software is actually suitable. But we don't need to define the mechanism for you reaching through it. That's not relevant to the SCITT building blocks. We just need to make sure that it is possible for appropriate chaotic applications on top to do that.
So, keep it short.
Hey, my name's Ben Gehring. I heard a bit of small proposal to switch something from like a string to bytes, which was either KID or ISS. Did that, I think you were advocating for, Ori? Does that sound right?
We can't change the definition of the registered claim names in their type system.
Or like, did you say you had a preference for being able to refer to like the issuer or the KID by as like a byte string versus just a string, or did I like?
Our preference is for the feed identifier to have structure, and since that's a new identifier, we have the opportunity to do that.
Got it. Okay, thank you.
Hi, Dick Hart again. I've read through the stuff, and I'm a little confused on the role of the transparency server and wondering why is it? It would seem to me, if I was just architecting this in my head, not really thinking an awful lot about it, but that the transparency server would verify what's in the statement, and then it would sign it. And so that we're not having to worry about the keys and things that were used on the initial issuing, that's all on the immutable ledger. And so we know that a validation happened at some point in time by the service. And so we don't have to worry, the consumer doesn't have to go and do that verification at some point in the distant future and be able to find the keys that are now gone.
Earlier versions of the work I discussed this concept, and related transparency services sorted in notaries. Their purpose was to authenticate the issuer, not to review whether the document the issuer had signed was authentic or legitimate. That's policy information that's outside of the scope of our mission.
Christopher Allen, Blockchain Commons. In the spirit of keeping the agenda short, we do have an hour-and-a-half side meeting scheduled today at 3:30 in Golden Gate 4 on the topic of what are potential requirements for this type, for some of these challenges. So, and we don't have an internet draft. We have a kind of a pre-internet draft that we're circulating for advice on how to write up some of these requirements. So if that's something you care about, we have an hour and a half.
Do you want to say something else?
Well, yeah, so famous last words. If anybody, because I know we've had some people coming in and out, if anybody didn't sign the blue sheets, please do. It helps keep the community healthy. And there's a QR code at the front here that you can just scan and check that. That was my last word.
Thank you. Thank you for coming. Okay.
I don't know how you do timing, but that was great. My timing is typically I speak too fast. Schools are too free. It's still the situation. Fine.